IEEE 802.11, it is a wireless network with QoS, in which section MAC protocol is first described, then recently proposed mechanism for QoS supporting, namely, it consists of two parts mainly: enhanced distributed coordination function, hybrid coordination function. IEEE 802.11 MAC protocol. It consists of, the main purpose is to broadcast the channel for transmitting data to the other stations. It supports two modes of operations. First one is DCF, second one is PCF. The DCF does not contain any centralized control, because in ad hoc wireless networks the DCF is used, because in ad hoc wireless networks there is no centralized or base stations is available to transmit the data from sender to destination. It uses the intermediate nodes or the relay nodes to transfer the data between the source and destination, while PCF required an access point. It means the PCF is an optionally used in the ad hoc wireless networks. All implementations of the 802.11 standard for WLANs must provide the DCF mode of operations, while PCF is optional. The time interval between the two successive packets is called as interframe spacing. There are four types of interframe spacing, IFS. They are short interface spacing, point interface spacing, distributed interface spacing, extended interface spacing. The relation between these interface spacing are short interface spacing less than PAFS less than DAFS less than EFS. The combination of both two interface spacing gives a new interface spacing called arbitrary interface spacing, which is used in the IEEE 802.11e to transfer the packets to check the whether it has the highest priority medium or lowest priority medium or medium priority medium. The relation between PCF and DCF is combined in a channel. Let's consider this is a channel which is superframes. Two superframes is divided with a TBTT divided. This part of the first section is given beacon with a high message, and the other first part is PCF and second part is DCF, and the same in the second superframe. First part is beacon, and next with followed with PCF and DCF. This is the management in the PCF and DCF in single channel. QoS support for mechanism in 802.11e. Generally, it supports real-time traffic, and the support mechanism are two parts: enhanced DFS and HCF. DCF and HCF. EDCF. Earlier said PCF and DFS gives AIFS. The AIFS priority is given to the nodes. It means the priority is given to the nodes to which the highest priority, lowest priority, or medium priority. There are three types of priorities: highest priority, medium priority, low priority. These priorities are given to the nodes. Let's consider there are three types of three nodes: AISF of I, AISF of J, AIFS of K. These are nodes. Let's consider the channel in the contextual period. First part is the busy medium, and let's consider some after SAFS and PAS of time. The first node AISF of I is allocated. This AISF of night is equal to DAFS, and which is equal to the SISF into 2 E plus slot. SIFS into 2 plus slot time, which is the first node time, which has the highest priority to transfer the data. And then second one is AIS of J, which has the medium priority, and after completion of the high priority data, the medium priority will send the RTS message. Next one, AIFS of K, low priority data. Coming to the high priority data is transferring the data. How the data is transferred? By using the RTS and CTS mechanism used to transfer the data. Whenever the high priority data is sent the RTS mechanism, after some SISF of time, it sends the CTS message, and after SISF of time, the high priority node will transfer the data, and after SISF of time, it sends the acknowledgement return backs. And after completion of the high priority data, the channel is free. Whenever sensing the channel is free, the medium priority data is come to as a high priority data, and it sends the RTS and the data is completed. And then the low priority data sensing the channel is completed after completion of the medium priority data. The low priority data will come to send the data by using RTS and CTS mechanisms. Our enhanced DCF is completed. Now HCF. HCF is hybrid coordination function. It combines the features of extended distributed coordination function and point coordination function to provide the capability of selectively handling MAC service data units, which is MSDUS. To select the capability to selective by MSDUS. In that manner, it has upward capability with both DCF and PCF. It uses a common set of frame action sequence, which means it uses a common set of frame action sequence during the both CP and ACFP. The HCF is usable only in infrastructure based. HCF is only used in infrastructure based that provide QoS, that is QBBS. Duration time in CFP, PFP and CAP. Let's consider this is a superframe of 802.11e. Let's consider the first part is a beacon of CFP is empty, and after some time this is an empty space which is used CAP, and after some empty space CAP, empty space CAP. HCF access mechanism. In this, consider this is a contention free period. This is HCQAP, and this is station 1 and this is station 2. Let's consider this is a beacon with a message hello is coming with some period of time, amount of time SF. For the first SASF occurrence time to the last completion of the SAF time is called as TXOP. After completion of first SAF time, the RTS message is sent, beacon or STS message is sent. After some SAF time, the CTS is sent from the station 1. Then after SAF time, the data is transmitted and acknowledgement is issued. This is the completion of the first data transfer. This part is called TXOP, from first SIFS to ending SIFS period. And for station 2, same procedure. The beacon now with hello MC comes to the some of SIF time. Then here the station 2 is sending, so here station 2 is sending, so what is message is sent from station 2, and then SIFS, CTS, SIFS, and data is transmitted and acknowledgement transmitted. This part is completed, then this part is called as TXOP. And then HCF with the infrastructure. HCF is infrastructure nothing but beacon is transferring CFP, as we have seen earlier with the 802.11 super frame, same as here, but here pooling through HCF mechanism will take place. What is CAP? CAP is nothing but in CP real-time data wants to send, then non-real-time data is saved. Generally CP wants to send only real-time data, but non-real-time data occurs and stops the transmitting the data. In such cases, CP can't transmit the real-time data. The CAP is used to transfer the real-time data by stopping the non-real-time data. Without infrastructure, we can't generate the data from one place to another place.